tables that have rows and columns, and you might have multiple worksheets or multiple columns. Now we interface with these tables either via something like PHP-MyAdmin, which is nice because it's just user-friendly and it simplifies the process. But you can also use, as you saw before, the command line. And we'll use the command line in a little bit to establish two separate connections to a database and see what can go wrong if we simulate two different users trying to, say, withdraw money from a bank account from two different ATMs without implementing the database checks properly, as we shall see. So consider this example. So thus far, you're probably familiar with SQL and selecting data, inserting, update, and the like. But let's make sure everyone's on the same page with regard to more sophisticated queries. Still pretty simple, though, using what are called joins. And these can either be implicit or explicit. So for the sake of discussion, assume that some database has two tables at the moment. There is an employees table, which has an employee ID column and a name column, the first of which is numeric, the last of which is strings. And then we have an orders column, which has a product ID, a product name, and an employee ID. And the employee ID signifies who sold that product to some customer. So just looking at these two tables, does anything rub you wrong about the design of this? And this is actually taken from a website called W3 Schools, which has plenty of things wrong with it. So here's one of them. What's bad about the design? Ignore the query. We'll get there. What's bad?
Just one employee can sell a certain product.
Okay, so well at the moment, okay, so think of this as this is orders. So who sold that product?
Well, if two employees sold a chair, that's not reflected in that.
Okay, so if you have two people tag teaming, maybe you have a trainee and the senior salesman. Okay, so we can't model that because we have to give credit to one person. That might be reasonable, but fair. Yeah.
If you had 30 sales of chairs, you'd have 30 rows for the same chair. You wouldn't have any.
Okay, good. So if the customer comes in and buys quantity 30, we're going to have 30 rows when, frankly, we could probably get away with one with an additional field like quantity. What else? Yeah.
There should probably be a products table that matches product IDs to products rather than just putting both of those in the orders table.
Yeah, this is what rubs me the wrong way the most. So these tables are not in what we'll call 3NF or third normal form. And this is just a fancy way of saying there's the potential for unnecessary redundancy in at least one of these tables. And by redundancy, we mean exactly this. Notice that you've got printer, table, and chair, and each of those is apparently uniquely identified by a product ID. And yet the implication of this orders table here on the right-hand side is that if we sell another chair, another printer, another table, not only is the product ID going to end up as in another row of that table, and that's okay, but so is the name, again and again and again and again, and it's just not necessary. There's an easy opportunity here to have, as you proposed, a products table, and what field should probably be in that products table? Yeah. Exactly, simple as that. So product ID and product name. Now the problem, of course, is that if you factor out product name from that table, but you want to execute queries in the future that give you back the person's name or employee ID, the product name, and the product number, it feels like you're going to have to select from this table, select from this table, select from this table. So we've gone from one SQL query to 3. For instance. Well, and that seems to suggest that we slowed things down just to be anal about keeping everything nice and neat. But the reality is this is how relational databases are meant to be used, and they allow you to join tables again so as to create temporary tables in memory that contain precisely the information that you want. So here's a simple example that doesn't even use yet the keyword join. If I want to select an employee's name and the product name, from these tables, I can do this syntax here. Select employees.name, comma, orders.product. So you just very explicitly mention not just the field name, but the table from which it comes. That's not strictly necessary. You can get away with just saying the field name if it doesn't exist in both places. Otherwise, it's ambiguous, but better stylistically, perhaps, to be ever so readable like this. From employees, comma, order. So you put a comma-separated list of the tables from which you want to pull this data, where employees ID equals employees ID in each of the tables. So in other words, this is implying that you should take this table here with employee ID and this table here, and if you can imagine in your mind taking one table, moving them around on the screen, and overlaying them in such a way that the employee IDs line up, what do you get? You get a slightly wider table that contains the information you care about, or specifically, all you're asking for back is name and product. So the table you get back is going to look like this. So all this while, if you've been using SQL before, CS50 Finance or the like, or this current project last week, what you're doing when you select is getting back result sets, but you can really think of those as temporary tables in memory. And so in this case now we can iterate over this as with MySQL fetch assoc or with CodeIgniter's equivalent, and we can print out that Ola sold this and Steven sold this and Steven also sold this. So what's the point here? Well, this is a very simple example, but certainly this model here is not going to scale very well. You're just going to have spending a ridiculous number of bytes for large data sets redundantly. Moreover, what's a future performance implication if you store table, 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 as well as its number 657 all over the place? Yeah?
So you want to change the name?
Yeah, something simple, right? Like you just want to change the name. Now you have to do an update on this entire table, change all these rows, which is going to trigger a re-indexing of that table potentially, which itself is going to be slow. So in short, there's just no reason to do this. So the goal of any table design, certainly for Project Zero, is to ask yourself, is there any redundancy here? And can I factor something out? Another canonical example is zip codes. If you are storing an address book of people, you've got a name, first name, last name, phone number, city, state, zip. Well, which of those should actually be factored out from that table? Yeah, so city, state, right? It might feel very natural to just have every row in the table have a user's entire address, but do I really need Cambridge, Mass for 02138, 02138, all over the place? Rather, I can probably use 02138 as a key, store only that in my address book table, and then have a zip codes table that maps zip code to city, state. Now, that's a bit of an overstatement because the US has made a mess of the postal codes, and so there are actually multiple city names sometimes for given zip codes. But that's sort of an orthogonal problem. But the idea of factoring it out is at least a good takeaway here. So let's be more explicit as to what we're actually joining here. So before, now after. So the syntax is slightly different, but it allows you now to express with the SQL join keyword exactly what you want to do. So let's select name and product from the employees table joined on orders. So the fact that I've written this on 3 lines, totally arbitrary. It's just for formatting's sake. So the table I'm selecting from now is employees join orders. But what do you mean join on those 2 tables? You have to specify. Join on employees.employee-ID such that it equals orders.employee-ID. So in other words, take these 2 tables and line them up in such a way that the employee IDs line up on both sides. Now, as an aside, there's other types of joins that might very well be relevant to even Project Zero or future projects. There's left joins, there's right joins, there's full joins, inner, outer joins. So this is an example this is the default join scenario. But suppose that one of these tables had, suppose there was employee number 5, like Malan, David, and he hadn't sold anything. Well, when you join 2 tables like this, they're only going to join rows that match in both tables. But if you wanted to ensure that even Malan, David appeared in the output, even though he's not sold anything, you could explicitly say, you know what, do a left join. Because why left? Well, literally in this case, employees is on the left, orders is on the right. But in terms of code, employees comes first, join orders. So if you put this all in one line, employees is on the left, orders is on the right. So a left join would say, make sure I get all employee IDs from one table, even if there's nulls in the resulting output. And sometimes you do care about this if you don't want to lose track of people or data. Yeah?
What is the benefit of this over your previous syntax where you just use where this equals that? It seems to do the same thing.
They do, in fact, do exactly the same thing. Part of it is just personal choice. And this actually, I would say this one actually makes a little more clear exactly what's going on. But to each his own.
So there's nothing that join can do that, just saying where equals what?
Well, so this is allowing us to do the default join. If you actually wanted to do left join, right join, then you obviously have to use the explicit keyword. So it's really up to you as to what style you'd want to practice. All right, so tuck that away, and now let's consider some issues of efficiency. So the database for Harvard courses for Project Zero is actually non-trivially sized. FAS has several thousand courses over the course of a year, and so searches could very well end up being somewhat slow, especially if your own laptop is slow and you're running the appliance and you're running a database server inside of the appliance. Ideal during development and playing around that you don't want queries to take a full second or 5 seconds, and you can actually mitigate against these performance issues by designing your tables in the right way. So primary keys, you're probably all familiar with. The primary key in a table just defines what? unique identifier for that table. So if you have a student's table, their Harvard ID number is probably the primary key. Or in the case of products, the product ID was probably the primary key. So beyond just specifying uniqueness, a primary key also gives you what's called an index. So MySQL and other database engines, Microsoft Access, Oracle, and the like, they build up for you at your request indices, so high performance data structures. They're typically B trees if you've taken CS124 or similar, and these are data structures that make